So in this video, we will be covering over trigonometric substitution, and there are three cases that you need to remember. The first case is that x is equal to a into tan delta. Now, we also need to go over the basic trigonometric stuff, which is, as you all know, so, ka, tua, which is sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. So here, if we isolate tan, so it will be equal to x over a is equal to tan of delta, right? And here we can conclude that x here is going to be opposite side of the triangle, and a here is going to be the adjacent side, right? And if we draw the right angle triangle, we will, okay, that was not the best triangle. Yeah, so this is 90. Let's call this the angle delta. So opposite is this side over here, so let's call it x, and the adjacent side to this angle is a. So how do you think we should calculate the hypotenuse? The formula for that right triangle is CAB. So C squared is equal to A squared plus B squared. I'm pretty sure you all know this. So here, this side will be equal to the square root of x squared plus A squared. So that's it. Now moving on, let's go to the second case now. So now the second case is that x is equal to a sine of delta. So here x over a is going to be equal to sine delta, and now we know that sine is opposite over hypotenuse, so x here is going to be hypotenuse, and a here is going to be the opposite over, oh my bad, so this is opposite and this is hypotenuse. So now if we calculate the missing side quickly, it will be, this is opposite, so x, hypotenuse is a, so this side is going to be equal to a squared minus x squared, and the entire thing is a square root. Now for our last case, case 3, I'm going to write it over here since I don't have space. It is x is equal to a secant delta. So here we know that x over a is equal to secant, and we know that secant is 1 over cosine. So here we can flip it, and a over x is equal to cosine delta. So here the triangle for the last case will be, okay, yeah, so the last triangle would be, so cosine is adjacent over hypotenuse, so let's call this will be a, hypotenuse is x here, so this side will be x squared minus a squared. So let me actually make more space and write it clearly, because these are the main important things. So it was x squared minus a squared. Now the most important things that you need to remember from here are the radicals, because you will see this in the question, the same format. So these are the three radicals that you need to remember. So these three radicals, you will see them in the question, and these substitutions will help you to simplify the integral. So these are the main important things that you need to remember, all three cases, the substitution and the radicals for each of them. So now let's start with a question example, and of course you need to remember these common integrals. So let me remove this, it's from my last video. So we have the question as the integration of dx over radical 4 plus x squared. So what do you think this radical is in the form of if we go back up? This radical is in the form of x squared plus a squared, right? So we know that we need to use the first case here. So here a is going to be 2. So since 2 squared is 4, and x here is going to be a tan delta, and a here we know that is 2, so 2 tan delta. Now we derive it, so we find dx, since we want to replace all the x's with deltas. So dx is equal to 2 secant squared delta d delta. Since the derivative of tan here is secant squared, that's why. So now let's replace dx with what we have over here, and let's replace x with our substitution, which is 2 tan delta. So now the integration of dx, which is 2 secant squared delta d delta over radical of 4 plus x squared, and x we know that is 2 tan delta. So let's replace x with 2 tan delta squared. Don't forget the square. Let me make this better. I know that my handwriting is not that clear, but yeah, so this is now what we have. So now let's simplify this radical over here and distribute the square. So now it will be equal to radical of 4 plus 4 tan squared delta, right? Now if we factor 4 outside, it will become radical 4 into 1 plus tan squared delta. And we know that this is an identity, right? 1 plus tan squared delta is equal to secant squared, right? So we can replace this part with secant squared delta, and now we can simplify this even more, and this will be equal to 2 secant delta, since the square root of 4 is 2 and the square root of secant squared delta is secant delta, right? So now we can replace this entire denominator with just 2 secant delta, right? So let me just erase everything, and this will become 2 secant delta. And now we can simplify this even more. So we'll be left with radical of cancel, and there will be a secant delta d delta left. And this we know how to integrate, right? Since I had shown before. Let me show you guys again. The integration of secant x is ln secant x plus tan x plus c. So let's do that here. So it's going to be the integration of secant delta is just ln secant delta plus tan delta. Pretty simple, right? So this is where we reach now, and you might be thinking we are done with the question. The only issue which is left here, when we use u substitution, we normally substitute back whatever we substituted u as, right? So here we had substituted delta instead of x, right? So we somehow need to go back to x here, and the way to do that is, so normally you would do like u is equal to, let's say, 3x squared and du and blah 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 dx, and then in the final answer you will substitute u with whatever you have here. But since we here did x is equal to 2 tan delta, this is where our triangle that we drew before comes in handy. So you have to draw the triangle now. So let's do that, and you'll see the things very clearly after we draw it. So here we have x over 2 is equal to tan, right? So here we know that this side is going to be the opposite side and 2 is going to be the adjacent side, since tan is opposite over adjacent. So here we can draw the triangle, and I'm going to call this the angle delta. So opposite to it is x and adjacent to it is 2, and this side will be equal to x squared plus 4, right? Simple stuff. So now let's go back to what we have over here. We have secant delta, right? And secant is 1 over cosine delta. So here, what is cosine? Cosine is so adjacent over hypotenuse, right? So what is the adjacent side to delta over here? It's going to be 2 over hypotenuse, which is radical x squared plus 4. And now since we want to find the secant, secant is just the reciprocal of cosine. So all we need to do is flip this. So it will become radical x squared plus 4 over 2. And that's it. So here we can replace delta with this part over here, or I mean in the entire thing, secant delta with this part, since we know that secant delta is equal to this. So let's do that. Ln of secant x squared plus 4 over 2, and tan we know from before that it is x over 2 simply over here, and that's it. And don't forget the c. So you might be thinking, why don't we just substitute back? Since delta over here is an angle, we can't just bring this to the other side and substitute back. We need to use the triangle over here. So this is how you simply do a question like this. Let's do 2 more examples. So let's move on to the next question. So here we have x squared over radical 9 minus x squared dx. So the first step we need to identify is which case is this from our cases over here. So it is our second case where we have a squared minus x squared radical. So here we can then identify that is a squared minus x squared, and here a is going to be equal to 3 sine of delta. And now we need to derive this to be able to replace dx with our delta. So here it will be equal to, so actually here a is just 3 and our x here is a sine of delta, and dx, of course you can replace 3 with a with 3 here. Dx is going to be 3 cosine delta d delta. Now let's replace dx with what we have over here, and also we're going to replace all the x's with our 3 sine delta, since we don't want any x's in our question. So the first thing in the numerator is x squared, so we're going to replace that with 3 sine delta squared over radical of 9 minus 3 sine delta squared, and dx over here is simply this part, which is going to be 3 cosine delta d delta, and we multiply this, and of course this integration. And over here we can simplify the denominator, so it will become 9 minus 9 sine delta squared. We can factor 9 outside, and it will become 9 into 1 minus sine squared delta, and we know that this part is cosine squared delta, and this will be simplified to 3 cosine delta, since the square root of 9 is just 3, and the square root of cosine squared delta is cosine delta. And we realize we can replace this entire thing with 3 cosine delta, right? Since we just simplified that right now. So it's going to be 3 cosine delta. And now we can cancel this with this part over here. And all we have left now is 3 sine delta squared. So let's simplify that now. So it will be 9 sine delta squared d delta, and we can take the 9 outside here, and here we realize that we need to use our half angle identity, because we cannot integrate sine squared, and the half angle identity is sine squared delta is equal to 1 minus cosine 2x, or 2 delta, sorry, over 2. So here we can replace sine squared with the identity. So it, it will be equal to, sorry, 1 minus cosine 2 delta over 2 d delta. And here we can take the 2 outside, since it's more easier to integrate like this. So all we now have left is 9 over 2 integration of 1 minus cosine 2 delta. Now we can integrate this, so it will be equal to 9 over 2, open brackets, 1 is going to become delta, minus sine 2 delta over 2, and close brackets. Now again, as before, we need to go to our x here and rewrite this in terms of sine. So it will be equal to x over 3 is equal to sine of delta, and we know that this is opposite, x is opposite, and this is hypotenuse. So we can now draw the triangle. This is our angle delta, and opposite is x here, and hypotenuse is 3. So what is this side here? Is going to be 9 minus x squared square root. So here, how do you think we should solve for delta first of all? We know that x over 3 is equal to sine of delta, right? So if we want to take sine to the other side to solve for delta, we can do arc sine of x over 3 is equal to delta, or we can also say sine inverse is equal to x over 3. So we can replace this part with our, actually let me go back and write it again. So it is equal to 9 over 2. This part is arc sine x over 3. But now how do we simplify this? Since we have the angle of sine 2 delta, and here we have only, in the triangle that we drew, we only have the angle of delta. So again, what we need to use? We use the half angle identity over here. There's another identity called the double angle, which is that sine of 2 delta is equal to 2 sine delta cosine delta. So if we manage to replace this over here to our original delta, we'll be able to use the triangle then, right? So let's replace sine 2 delta over 2 with this part over here. So the 2 will cancel out with the fraction over here, and all we will be left with is sine delta and cosine delta. So it's going to be equal to sine of delta minus cosine of delta. So now again we need the triangle to be able to solve for sine and cosine. We know from the our identity that sine is just x over 3, so we can replace sine with just x over 3, and cosine we need to solve for it. So let's go back to our triangle here. Cosine is adjacent over hypotenuse, so adjacent side is 9 minus x squared radical over hypotenuse is 3. So this part is going to be multiplied by radical 9 minus x squared over 3, which is just 3. So here let's just simplify. So let's distribute 9 to cancel out this 9 over here. So the final answer would be 1 over 2 arc 9 arc sine, or you can also write like sine inverse of x over 3. Here we'll have x radical 9 minus x squared, and realize that we had the 9, but we distributed the 9 over here. This is going to get cancelled out, and this is the final answer, and you can add the c now. So now let's move on to our last example. This last example is going to be more challenging than these two, so focus, and let's start with it now. So the question is radical of dx over radical 25 x squared minus 4. So now you guys realize that we are in the third case now, but there is something wrong over here. There is a coefficient for x squared, and in our formulas, if I go back, we don't have a coefficient for x. The coefficient of x is 1 here, the coefficient of x is 1, and for the case that we are doing, the coefficient of x here is also 1. So somehow we need to get rid of that 25 into 1. So here we can write the identity that we are using. So x is equal to a secant delta, and we need to somehow factor this 25 out. So I'm going to take it to the other side. 25 into x squared minus 4 over 25, and you realize that we can take the 25 outside, since we can take the square root of 25, which is 5. So 5 is going to be here, and remember this is the denominator, so it's going to be 1 over 5, and we can take that outside. So now let's simplify it. It will be equal to 1 over 5 radical of dx over, now the square root, the new square root is x squared minus 4 over 25. So here now let's find x, which is going to be the square root of 4 over 25, which is just going to be 2 over 5, which is, I'm going to keep it in fractions. I don't want to convert it into decimals. And here is our x. So now let's continue. Let's find dx now. So dx, I'm going to write it over here, is equal to 2 over 5, and the derivative of secant is secant tan. So here is going to be secant tan delta, and don't forget d delta. So now let's replace dx with our this part over here, and let's replace all the x's with 2 over 5 secant delta. So now let's plug in the values, or the x dx and x's. So it's going to be equal to, I'm going to write it over here, 1 over 5 radical of dx, which is this part over here that I underlined, 2 over 5 secant delta tan delta d delta over x squared is going to be 2 over 5 secant, then brackets, and then x squared, squared. So here let me make the radical, x squared, let me open brackets, 2 over 5 secant delta squared minus 4 over 25. So now let's simplify the denominator. So I'm going to do it on this side here. It's going to be 4 over 25 secant delta squared minus 25, 4 over 25, and then you factor 24 over 25 outside. So this becomes 1 over 1, and we realize that this is identity, right? So here this part is equal to tan squared delta, and this entire thing is going to be under a radical, don't forget that. So let me just replace this with now actually tan squared delta, and now we can find the square root, which is going to be 2 over 5 tan delta. So this entire denominator can be replaced with just 2 over 5 tan delta. So that's always the first step that you need to do, simplify the denominator. And now we can cancel out 2 over 5 over here, we can cancel out tan, and all we have left over is just secant delta, right? So let me just write it again, secant delta d delta. So now let's integrate it. So as we know from before, the integral of secant is going to be ln of secant delta plus tan delta. So now again we need to replace our deltas back to what we have from x. So here let's write the triangle and make the triangle and write the secant in terms of x over something. So here x over 2 over 5 is equal to secant, right? And we can take this 5 up, so it's going to be 5x over 2 is equal to secant. And if we convert this to cosine, since secant is 1 over cosine, the cosine is going to be equal to 2 over 5x is equal to cosine delta. Since you know secant delta is equal to 1 over cosine. So all I did is just flip it and write it in terms of cosine. So here actually we need to replace first of all secant delta with what we have over here, 5x over 2. So we can do that right away, 5x over 2. And now we need to draw the right angle triangle to find what is tan delta. So let's draw the triangle. Oops. So this is our angle delta, and we know that delta, cosine of delta is so it's adjacent over hypotenuse. Adjacent is going to be 2 and hypotenuse is 5x, and our last side, which is the opposite side, is going to be radical of 25 x squared minus 4. So now tan, as we know, is so-called toi, opposite over adjacent. So the opposite side over the adjacent side, which is 2. So here we can replace this with opposite, which is radical 25 x squared minus 4. And I do apologize for my handwriting, I know it's not that clear, over the adjacent side, which is just 2. And don't forget the c. And now we can simplify this because we can find the radical. So let's do that. Actually, I'll leave the c for now. Let's simplify it first. Or what we can do is merge these, since these two are the same denominators. So the final answer would be 1 over 5 ln of 5x plus radical 25x squared minus 4 all over 2 plus c. And here is the final answer. So I know this is a bit confusing and a lot to remember, and it is a bit challenging, and as always I do have a shortcut method for you guys. So you need a calculator which can do integration, of course, with the two limits. And let's take the question 3 as an example on the calculator. And the second thing that you need to do is to convert your angle unit to radian instead of degrees. So this is another very important step if you want to recheck your answer. So just type any two limits, let's say 0 and 1, but in our case here 0 and 1 won't work because this radical below will somehow be negative and we can't have a negative inside our square root. So let's try 0.1 and 1, the two limits. 0.1. So this is a try and trial. You keep trying because 0.1 also does not work. So let's try 1 and 2 maybe. Okay, so 1 and 2 works, and we got the value of 0.14512. You will get the exact same answer, so it's better to write it down, something like this. Okay, so now you go back to your final answer and you substitute back the two values that you chose, which is 1 and 2. So first of all you will choose you will substitute 1. So 1 over 5 multiplied by ln of absolute value. You have to type exactly what it is. Now you have to substitute x as 2 first. This is going to be 5 times 2 plus the radical of 25 and 2, x is 2 here, the 2 squared, minus 4 over 2. Now close the brackets and minus, okay, there's 2 brackets, so I think I only closed one of them. Yeah, now I close both of them, minus the same thing, 1 over 5, but this time you will substitute x as 5 now, I mean x is 0, sorry. So 1 over 5 ln absolute value 5 times 1 is going to be 5 plus radical 25 minus 4 over 2, close. And as we see, we got the exact same answer, 1.451264865, and you will realize that we got the same answer as before. So this guarantees, this tells you 100% that your final answer is correct. So this really comes in handy if this was a MCQ question. You can try all your options. So it does take a time. So you can only do this if you have like extra time left, or you don't know how to do the question and it's an MCQ question. But if you need to show your workings and everything, then of course you need to learn how to do it. But yeah, thanks for watching. I will be making a short video to show you guys how to do this on the calculator, since it's of course more easy to show you guys. And if you have any questions, you can ask them in the comment section. I'll be more than happy to help. And thanks for watching.